In this episode of Scaling Postgres, we talk about pluggable storage, developer gotchas, cursors, and Postgres 12. I'm Preston Jameson, and this is Scaling Postgres, episode 60. All right, I hope everyone's having a great week. Our first article is PG Phriday, Around the World in 2 Billion Transactions. And this is from the second quadrant PostgreSQL.com blog. In here, they're talking about the issues of transaction IDs or XIDs, and that the fact that they are limited to 2 billion transactions based upon the fact that they're using 32 bits for this counter. Now, this can be an issue because if you have a lot of activity, you can run out of them. And they mention some high-profile incidences of this happening. And that as databases are processing more data, this becomes an ever bigger limitation. Now, I have covered some previous articles where they're talking about making it 64 bits to lengthen the runway on it a bit. But here, they're talking about reframing the problem and how to kind of think about this and what's the way forward. And a lot of people just say monitor it. But as more database use cases have higher and higher volume, the amount of time you have to deal with a potential problem gets smaller and smaller the higher the activity. So you definitely need to monitor your XIDs, but given your volume, you could run out of it pretty quickly. Now, one thing they mention here is a way out of this, because they talk about you could change it to 64 bits, but that would require a lot of work to do. And if you already have a large database, they frame the question here, that would mean a very time-consuming and antiquated dump and restore procedure, so you couldn't use something like PG upgrade. And they say, quote, who wants to spend days or weeks transferring 50 terabytes worth of data to a new target that removes the XID issue? So even if we were able to make 64-bit XIDs, the problem is transitioning large databases to it. But interestingly, he mentions under this heading, a way out. And the point he's referring to is Andres Winand, I believe as part of Postgres 12, he posted Postgres now has pluggable table storage. And why this is beneficial is that once data storage becomes decoupled from the engine itself, a whole new world opens up. So instead of having to do a whole database transition upgrade at once, maybe you could create a new table storage engine with 64-bit IDs and transition it that way. And they also mentioned some of the backends, like Enterprise DB is currently working on ZHeap, which maybe it could use this pluggable storage. And this type of storage engine, some of the advantages, maybe we wouldn't need vacuum anymore. Maybe we wouldn't need to vacuum up rows anymore, and updates could be done in place without having to keep a copy of that row around. So basically, this offers a way forward potentially to moving from the 32-bit limitation on XIDs. So it's definitely a very interesting article, and I definitely encourage you to check it out. The next post is actually a YouTube video, and it's PostgreSQL Gotchas for App Developers by Magnus Hagander. And this was at the FOSS North, on the FOSS North YouTube channel. And this had some great advice for developers using PostgreSQL on gotchas to watch out for. And I'll list a few that occur in the video, like they're talking about the importance of pooler size and perhaps basing your connections on the number of cores. In other words, you don't want 10,000 connections going to the database when you only have 10 cores in your database system. How it's important with regard to the security notices that have been released is that the user you're using to connect as your application, you don't want that to be a super user. You want it to be a generic user, or at least owner of the schema that you're working with. You want to be sure to turn off trust in your PG HBA file, since that bypasses the network security in place. He talks about different ways you could use JSON, as well as some best practices with regard to migrations. He also talks about cautions when using CTEs, or common table expressions, which is the with clause, because PostgreSQL tends to materialize those. However, in Postgres 12, you have I believe they don't do it by default, but you can choose to materialize them if you so choose. And then he has a whole nother section talking about ORMs and how best to work with them with your application with PostgreSQL. So if you're a developer, definitely really great presentation to check out. The next post is Declare Cursor in PostgreSQL, or How to Reduce Memory Consumption. This is from cybertech-postgresql.com, and this is a post about cursors. Now, I actually haven't used cursors that much in PostgreSQL. I did use them more when I was an Oracle DBA, but I haven't used them any from my recollection in PostgreSQL, but they have cursors. And they're talking about specific use cases where they can be beneficial. In other words, in this scenario, he put 10 million rows into this table, and he just did select everything from the table, and it takes forever loading that data in and pulling it from the database. So you're pulling everything at once. Whereas if you use a cursor, it allows you to fetch a certain number each time. So with this first one, he can immediately fetch one of the rows. And then when he fetches the next 4 rows, it gives him the next 4 rows from his cursor. So imagine a screen cursor, and it saves the place of where you are, and you can get one record and then another 4 or 10 or however many you need. But you have a main query, and then you move that cursor along within that data set you've pulled, and it should return the data much faster because it's only pulling back for you specific amounts of information that you need. And here are some of the different capabilities, like you can move to the next or the prior or the first, the last, moving forward, backward. So all of these commands to be able to move the cursor throughout the data set that you're selecting. Now, one thing to keep in mind is that these do have to be within a transaction. So normally when I had used cursors, it was within a stored procedure. But it's just something to keep in mind when you're using cursors, it generally has to be within a transaction. However, they do have a section here saying using cursors across transactions, which they say here, to make sure the data can survive the transaction, PostgreSQL has to materialize the result. So when you do this select, it does materialize the result, and then you can use it for a period of time until you close out that cursor. So if you're needing to work on a particular data set and move forward and backward through it, retrieving data, perhaps cursors could help you get better performance for the activity you're doing. So this is definitely a blog post to check out. The next post is how to update objects inside JSONB arrays with PostgreSQL. And this is freecodecamp.org. And basically, this is a post about working with JSONB in PostgreSQL. And he's assuming the scenario, you have a customers table, and maybe you want to store contact information in a JSONB in this type of format where you have a phone type and a value. Although if you looked at the gotchas for Postgres video, they would definitely endorse having a separate email phone column, a separate email column, as opposed to using JSONB to store it. However, you may have use cases where this is beneficial to do it. And this post focuses on how you can update a single area of this JSONB without having to rewrite the entire contents. Now, for doing that, you can use the JSONB set function that's part of PostgreSQL. And he goes over how to do it so that you can specifically look for and update one of those elements you need without having to rewrite the whole JSONB. So if you use JSONB in your database or applications with PostgreSQL, definitely a blog post to check out. The next series of posts are all about new features that are slated to be coming with PostgreSQL 12. The first one here, and these all start waiting for PostgreSQL 12, and actually 3 posts in a row from depesz.com. And the first one is report progress of create index operations. Now for me, this is huge. So finally we get insight into what a create index or create index concurrently statement is doing, because currently you can't really track. The only way that I've found to do it is maybe monitor the size of the index as it's being built. But this commit for Postgres 12 actually creates a pgstat table called pgstat progress create index. So it lets you know at what stage things are, like you're scanning the table, you're loading the tuples in the tree. So I like what he says here, and I agree wholeheartedly. This is amazing, thanks to all involved. So for me, this was definitely the best thing to see, because this would be so welcome when you're building indexes on terabyte plus databases. The next post is generated columns. Now, I also found this very interesting. Now, this is part of the SQL standard. I'm not sure which SQL standard it is, meaning what date it was put in, but it lets you establish a computation to apply for a stored column. So it does stored column as opposed to virtual. So for example, they have one int, a second int, and then a third int that is calculated for you. So you don't do anything. It's essentially read-only to you, but you say whatever value is in the first column, add it to the second column. So for example, when you insert into this table, again, you don't insert into the generated column, but you insert into the other two columns, like 1 and 2, and it will automatically calculate and update the value to be 3. And then here you can even use update statements to set the second column to 5. Now it will calculate that sum again to be 1 plus 5 equals 6. So it will always maintain what calculation you define. And again, this is called generated columns. Now, presumably in the future, they're going to be offering a virtualized calculation, so it actually won't store it. But in this first release for this feature, they are doing the stored columns. And they talk about historically you had to do this through triggers, but this mechanism is much more efficient. Like he did some testing and it was twice as long to use a trigger to do this type of functionality versus using generated columns. So if this feature is of interest to you, definitely something to check out once PostgreSQL 12 gets released. And the next in the series of posts are log all statements from a sample of transactions. So this goes to when you're looking in your logs for PostgreSQL and maybe you have set a logmin duration statement and say it's set to print out every slow query that's greater than a second. So this is very beneficial to find slow queries. What this offers is it adds a log transaction sample rate. And here it's set to 0.001 or 0.1%. And what this does is it takes a 0.1% sampling of all the slow queries. So basically it makes your log much smaller. Now you don't get all the slow queries, of course, because you're taking a sample, but at least you get insight in some example queries that are slow in your system. So of course the benefit of this is less logging. With some of the testing that he did in this post, it resulted in a dramatically smaller log. So if you have a lot of transactions going through your database in very large log files, this may be a feature you want to check out with PostgreSQL 12. The next post, again related to Postgres 12, is new in PG12, statistics on checksums errors. And this is from our juju.github.io. Now we had talked about this in the previous episode of Scaling Postgres, the data checksums that was introduced in 9.3, but you basically have to do it at database creation or a cluster creation if you want to enable these. With 12, they are adding a mechanism to enable this on existing clusters. But this post is talking about new counters that are available in the pgstat database view that makes checksum errors easier to monitor. So it basically lets you track these checksum failures by checking your pgstat database. And it tracks validation errors both for the backend activity as well as base backup activity per database. And it shows a cumulative number of errors and the checksum last failure. So again, this is a really great feature that's being added to PostgreSQL 12. And if you want to learn more, definitely check out the blog post. The last piece of content is another YouTube video, and it's called The Mother of All Query Languages, SQL in Modern Times. And this is from Markus Winand. Now this presentation is really interesting and kind of opens your, or at least opened my mind up with regard to SQL and all the advanced modern features that are being added. Now it's a little bit on the cutting edge because even a lot of the features that are in the standard, even as a few years ago, haven't even made it into all of the major database platforms. Now PostgreSQL has a fair number of the features he mentioned, but some of the, like a few of the kind of the mind-blowing ones aren't even a part of PostgreSQL now. But if you definitely want to get more insight into the power of SQL and what it can do and what features are probably going to be eventually added to PostgreSQL as well as other relational databases, or actually he didn't like the term relational, but SQL-based databases, definitely a presentation to check out. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.